Hi everyone, and welcome to another one of my videos. This video is a help video that takes you through the non-calculator assessment preparation questions that I gave you earlier on this week, and hopefully gives you some pointers for some of the questions so that you can work and prepare yourself for the assessment. Now, I haven't done every question. Why? Because some of them we'll do in class, and some of them needs me to explain a bit more in class. And some are pretty easy, and so I think you can do them without any help. Some are repeat questions, and so if I show you how to do one question, hopefully you can learn how to do the other questions and use them as practice. And what I've done with a few questions is I've changed the numbers and shown you how to work out a similar question. So let's go. So this question here should be fine. This question here should be fine. Let's look at this one here. I've changed the numbers. The normal price of a television is reduced by 40% in a sale. The sale price of the television is £480. Work out the normal price of the television. Now, what you need to find is the original 100%. Now, what a lot of people do is they think to themselves, right, okay, well, I'm reduced by 40%, and now it's this. So if I find 40% of this and add it on, I'll get back to the right price. Well, you don't, because this is a smaller number. And it was 40% of the original number that was taken off, not 40% of that. So if you take off 40% and then put 40% back on, you don't get back to the start. For example, £100, take off 10%, it's 90. Add on 10%, which is 9, you're on 99. You don't get back to the original, because in my case, you took off 10% of 100, but you only put on 10% of 90. So the way to do it is this. First of all, if 40% is taken off, then 60% is left. So this represents 60% of what it used to be. So let's write that down. 60% is 480. Now what we want to work out is the 100%. So I noticed that 48 and 60 are both in the 6 times table. So I'm going to divide them both by 6. Remember, this is a non-calculator method. So divide that by 6, I get 10%, and that makes 80. So 10% is 80, and now easily 100% is 800. And that's how you need to do the question with the actual numbers. Question 4, change this into a mixed number, and change this into a mixed number. Multiply the top numbers, the numerators, multiply the denominators. That one should be fine. This one here, round each number to one significant figure, and then do the calculation. Don't try and work it out exactly and then round it off. That's not what an estimate is. Here, once again, it's an estimate. So don't work out 2.7 litres times 28. Round each number to one significant figure and then do the calculation. Here are some questions where I've changed the actual questions so that I can show you how to do it, and then you've got the actual original questions that you can practice on. So question 8 says simplify, and in my case, a to the power of 6 times a to the power of 8. The fact you've got an a and an a means it's the same number. And when it's got the same number and you're multiplying them, you simply add the powers. So for my case, it's going to be a to the power of 6 add 8, which is a to the power of 14. And then you've got something that looks really horrible, but actually is fairly simple. It says simplify this expression. Well, what have you got? You've got some numbers, you've got some g's, and you've got some h's. And the way to think about it is just to separate it. Separate the numbers and the g's and the h's. So this is 36 divided by 4, which is 9. Then the g's are going to be g to the power of 10 divided by g to the power of 7. Well, you subtract the powers when you divide, just like you add them when you multiply. So that's going to be g to the power of 10 take away 7, 3. And this is going to be h to the power of 5 divided by h, which is like there's an invisible 1 there. So it's 5 take away 1, 4. So basically the knack is to separate everything. Separate the numbers, separate the different letters, and work out each individual answer, like I've done here, and then basically stick it all back together again. Write down the value of 16 to the power of a half. Well, anything to the power of a half is the same thing as a square root. That's literally what it means. It's another way of writing the same thing. So something to the power of a half is a square root. So 16 to the power of a half is the square root of 16, which is 4. So question 9 says q to the power of x times q to the power of 6 is q to the power of 13. Find the value of x. Well, when you multiply, you know that you add the powers, so x plus 6 has to add to make 13, and therefore x must be 7. Here, you've got 5 cubed to the power of y equals 27, or 5 to the power of 27. Find the value of y. Well, when you raise a number to a power and then to another power, you can write that more simply by just multiplying these powers. So, for example, 5 squared to the power of 3 would be 5 to the power of 2 times 3, 6. So 5 to the power of 3 to the power of y can be written as 5 to the power of 3 times y, or 3y. So we know that 3y in that case has to be equal to 27, and so therefore y must be 9. The next question says 100 to the power of a times 10,000 to the power of b can be written in the form 10 to the power of w. Show that w is 2a plus 4b. Well, we've got to write these numbers as powers of 10, and you can see that 100 is a power of 10, it's 10 squared, and 10,000 is a power of 10, it's 10 to the power of 4. So rather than write 100 to the power of a, we change that and write 10 squared to the power of a. And rather than writing 10,000, we write 10 to the power of 4 to the power of b. And we know from what we did up here, what we revised up here, is that that can now be written as 10 to the power of 2a, 2 times a, multiplied by 10 to the power of 4b. And we can now, because we're multiplying, when we multiply we add the powers, so this is 10 to the power of 2a plus 4b. So all of this works out to be 10 to the power of 2a plus 4b. So if we write that in the form 10 to the power of w, this power must be 2a plus 4b, and we've proved it here. This is how we've shown it. Question 10 says write down the value of 64 to the power of a half. Well, I just did that in question 8c, so look at what I did there. B says find the value of 64 over 1,000 to the power of minus 2/3. Well, the first thing you need to know is that when you have something to a negative power, you flip it upside down and get rid of the negative. So 64 over 1,000 to the power of minus 2/3 is 1,000 over 64 to the power of 2/3. That always works. And you can split these numbers and do each of them to the power of 2/3. Now, what does 2/3 mean as a power? Well, a third is a cube root. 2/3 is a cube root squared. So 1,000 to the power of 2/3 is 1,000, cube root of 1,000 squared. And 64 to the power of 2/3 is the cube root of 64 squared. And each of these numbers are cube numbers, so we can write them and find the cube root of them. 1,000, cube root of 1,000 is 10, squared is 100. The cube root of 64 is 4, squared is 16. So our final answer is 100 over 16. Write 5 minus the root of 7 all squared in the form a plus b root 7, where a and b are integers. So when we square a bracket, we times it by itself. And whenever you have an expression like this, remember you always multiply everything in one bracket by everything in here. And I've drawn these lines to make sure that I don't lose track of what I'm multiplying. So it's 5 times 5, 25, and 5 times minus root 7, which gives me minus 5 root 7. So everything in here has now been multiplied by the 5. Now I multiply everything in here by the minus root 7. So it's minus root 7 multiplied by 5, giving me another 5 root 7, plus, why plus? Because it's minus and a minus, and multiplying makes positive, root 7 times root 7. So let's have a bit of a tidy up. Minus 5 root 7 and minus 5 root 7, we've got 5 lots of root 7 and another 5 lots of root 7, so together that 5 and that 5 make 10 lots of root 7. The square root of 7 times the square root of 7 is 7. Okay, I hope you realise that. The square root of 4 times the square root of 4 is 2. Is 4 rather. Okay, square root of 16 times the square root of 16, 16. So basically we've got numbers and we've got surds, square roots. So 25 add 7, 32 minus 10 root 7. Here you're going to do exactly the same thing as you did up here, multiplying everything in here by everything in here, just being careful that you've got a negative sign there. Okay, and just like I did, Okay, you'll have root 2 times root 2. Think about what that will be. Okay, and you should have some surds and some numbers. Put the surds together, put the numbers together, like I did here. Okay, here I've changed the numbers so you can practice on the other one. So we've got root 2 times root 27 plus root 48 can be written in the form a root 6, where a is an integer. Find the value of a. So whenever we're breaking down surds, we're looking for square numbers. Numbers that go into this, the biggest square number that go into these. So 27 can be written as 3 times 9. And 48 can be written as 3 times 16. Okay, and I've chosen those numbers because each time I've got a square number. Okay, now you might say, hang on for a minute, 48 is 4 times 12 as well. Yes, it is, and 4 is a square number. You're right, but we look for the biggest one if we can find it. So 48 is 3 times 16. Now, one of the rules of square roots is I can split this up further. The square root of 3 times 9 is the square root of 3 times the square root of 9. The square root of 3 times 16 is the square root of 3 times the square root of 16. And now you can see why I've done it, because this part I can actually find the square root. I can find the square root of 16, it's 4. So this is 4 lots of the square root of 3. And in the same way, the square root of 9 is 3. So this is 3 times the square root of 3. Now what have I got? 3 lots of the square root of 3 plus 4 lots of the square root of 3. So altogether, I've got 7 lots of the square root of 3. Multiplying it by the square root of 2, I combine these numbers, and that gives me 7 root 6. 6 from the 2 times the 3. Here, you should be okay with that. Just gather together the x's, gather together the y's, gather together the numbers. Factorizing, giving you a couple of examples. Say you have this. Basically what you do is this. Separate the numbers from the algebra. If the algebra contains more than one letter, do the letters in turn. So, 6 and 18. What's the biggest factor they both share? It's 6. Now we've got a's. Look at the a's. We've got a squared and a cubed here. What's the most a they both have? It's a squared. Then we've got b here, but we haven't got a b here. So there's no b that they share. So the most that these two expressions share is 6a squared. So that goes outside the bracket. The bit that they share goes outside the bracket. Okay, what goes inside the bracket? Well, 6 times something has to make 6a squared. Well, I've already got 6a squared, so I just need 1. So that 6a squared times 1 makes 6a squared. Now I'll put a negative sign here because I've got a negative sign here. To make 18, well, I've already got 6, so I'll need 3. So that 6 times 3 makes 18. I need a cubed. I've got a squared. I'll need an extra a. I need a b. I haven't got one, so I'll need one here. So 6 times 3 makes 18. A squared times a makes a cubed, and times b makes b. That's this expression factorized. Here's another one, slightly more complicated. Separate the numbers and the a's and the b's. Look at the numbers. What's the biggest factor they share? 2. Now the algebra. I've got a's, I've got a's. What's the most they share? A. They've both got an a. I've got a b and a b squared. What's the most they share? A b. So, the most that they share is 2ab. Now, whatever I put here, this times this has to make that. So I've got a 2. To make 14, I need to have a 7. I need a squared. I've got an a, so I'll need an extra a. A times a squared. I've got a b. I need a b. No need to add anything more. Subtract, so subtract here. To make the 12, I need a 6, so that 2 times 6 makes 12. I need an a. I've got an a. I need b squared, but I've only got a b, so I add an extra b here. So quick check. 2 times 6, 12. A, b times b, b squared. 12ab squared. Here, multiply everything in here by the minus 3. Remember, both things by the minus 3. Then, gather together any numbers, and gather together any letters. In here, like we did before with two brackets, when the surds, multiply everything in here by everything in here. You should have 4 bits. Gather together the bits that are the same type. Gather together the x's. Exactly the same thing here. Factorize. When you see x squared and a number here, especially if that number is a square number, that should remind you of the difference of two squares. Okay? Because 64 is a square number. And so you put x minus 8 and x plus 8. And the reason that is because you get x times x, which makes x squared, minus 8 times plus 8 makes minus 64. But there's no x's here because that is minus and that is plus, and these are both the same. You'd get minus 8 times x, which is minus 8x, and x times 8, which is 8x, and the minus 8x and the 8x wipe each other out. So basically there's a pattern. Okay? If you had x squared minus 25, it would be x minus 5, x plus 5. X squared minus 100, x minus 10, x plus 10. Oh look, I've done that one for you. Factorize. Split into two brackets. Okay, put 2x in one, x in the other, and work out what else must go. The two numbers in each bracket need to multiply together to make minus 15. Here, think about what it would be if it was g to the power of 9 divided by g to the power of 3. Okay, well it's not g, it's g minus 7, but it's in a bracket. So it's g minus 7 to the power of 9 divided by g minus 7 to the power of 3. Just be confident and stick to what you know. What is the rule when you are dividing? What do you do with the powers? This bit here should be fairly straightforward. Remember, combine the numbers and the algebra. What's 5 times 4? How would you write f times g? This one here is fairly similar. Multiply everything in here by the 3 and then have a tidy up. You'll have some a coming out of here. Put it with this and tidy it up. You know what to do with the numbers when you multiply. You know what to do with the numbers when you raise a power to a power. You know how to factorize. This one here, solve it in exactly the same way as you would solve 3x minus 5 equals 16. But put this less than sign in instead. Okay. Here is a similar question. We've got 12 minus w divided by 2 equals 3 plus w. The first thing I do is get rid of this 2 by multiplying both sides by 2. That gives me 12 minus w equals 2 lots of 3 plus w. The next thing I do is I get rid of the brackets. I get 6, 2 times 3, add 2w. Now I need to have a bit of a tidy up. I need to get the w's on one side and the letter and the numbers on the other. Okay, I always get rid of the w or the letter where there's the least amount already. It makes life more simple. So I've got 2w here and I've got minus w here. Minus 1 is less than 2. So there's less w here. This is what I get rid of. I get rid of it by adding w. And so I add w here. That leaves me with 12 equals 6 plus 3w. 2w plus w. Now I've got letters just on one side of the equation. So now I need to get rid of this 6. Taking 6 from both sides gives me 3w equals 6. And so w is 2. This question here, we solve like a quadratic and temporarily imagine it to be x squared equals 2x plus 15. Now I know it's not, and we'll come back to that in a minute, but first of all we need to solve it. So let's imagine it's x squared equals 2x plus 15. To solve the quadratic, what we need to do is get everything together. So I take this, I take away 2x, and I take away 15 from both sides, and that gives me x squared minus 2x minus 15 equals 0. Now I factorize. I'm looking for two numbers that multiply together to make minus 15 and which add together to make minus 2. And the numbers are 3 and minus 5. 3 times minus 5 is minus 15. 3 add minus 5 is minus 2. So now I can see that x is either minus 3 or plus 5. Now, that's the solution if it was equal to 0, but it's what must the values be if it's more than 0. Now, I use this solution to help me because these values of minus 3 and 5 would be where this graph would cut the x-axis. The first value is 5, okay, and the second value is minus 3. It's here. Now, knowing what the shape of the graph looks like, I can see that between these numbers, it's less than 0. But this side and this side, where I've coloured it in green, it's more than 0. So the solution for this being bigger than 0 is that x must be bigger than 5, or x must be less than minus 3. Okay, but it came about by factorising and solving for it equals 0 first of all. This question here, you'll do in the same way. Get rid of the bracket, and then take everything over to this side like I did up here, and solve it in the same way. Question 21. There's something that we haven't done yet, and it is that two gradients are perpendicular if they multiply to make minus 1. So if something has a gradient of 2 and something has a gradient of minus a half, together when they multiply they have an answer of minus 1, and the two lines would be at right angles to each other, perpendicular. So another way of saying that they multiply together to make minus 1 is this. If you have a gradient of 4, then flip it upside down a quarter and make it minus. And if it was minus already, make it plus. So I've changed the question to give you an example. The straight line L has equation y equals 4x minus 5. Find an equation of the straight line perpendicular to L, which passes through minus 2, 3. Well, the gradient of y equals 4x minus 5 is 4. This number here, what's called the coefficient, the amount of x, is always the gradient. The bigger the number, the steeper the line is. So the gradient of this line is 4. So the perpendicular line will have a gradient of minus, because that's positive, a quarter, 4 upside down. So we know something about the equation of the line now, this perpendicular line. It will be y equals minus a quarter x add c, and we need to find out what this c is. So what do we know about this line? Well, we know that it passes through minus 2, 3. And that means that when x is minus 2, the y must be 3. When x is minus 2, the y is 3. So here's my equation of the line. Y equals minus a quarter x plus c. And y is 3, and x is minus 2. So, what have I got? 3 must equal minus a quarter times minus 2. Minus times a minus makes a plus. 2 quarters are a half. So a half plus c makes 3. And that means that c must be 2.5 or 5 over 2. So the equation of the line is y equals minus a quarter x plus 5 over 2. Question 22 says write down an equation of a straight line that is parallel to the straight line y equals 3x minus 5. It says an equation, not the equation, because there will be loads of equations of straight lines that are parallel to this one here. Remember what we said before. This line, going up here, has got a gradient of 4. Okay, this is the steepness. Now if a line is parallel to this one, it will have the same steepness. So what does that tell you about one of these numbers? See if you can now write an equation that's parallel to this one. This question is similar to the one we did up here, question 21. So maybe you can use that to help you do question 21. Question 23, A and B are 2 points. A has coordinates minus 2, 4, and point B has coordinates 8, 9. C is the midpoint of the line segment AB. Find the coordinates of C. Well, if C is the midpoint between A and B, it must be halfway between the 2 points. And that must mean that the x value is halfway between minus 2 and 8. And the y value must be halfway between 4 and 9. And hopefully that's given you a way of working out what the y value and the x value must be, and the coordinate of C. D is the point with coordinates 100, 56. Does the point D lie on the straight line that passes through A and B? You must show how you work out your answer. Well, this is a tricky question. First of all, what you need to do is find the equation of the line that joins these 2 points. Now, if you can't remember how to do that, look it up on Corbett Maths, or I can show it to you. Now, then, once you've got the equation of the line, you can see if you put x into the equation, does it calculate that y is 56? If it does, then you say D lies on the line. And if it doesn't, you say D doesn't lie on the line. The straight line has equation y equals 3x minus 4. Write down an equation of the line parallel, so it'll have the same steepness, the same gradient as this line, that passes through the origin. Now, remember, this value is where it crosses the y-axis. What would be the value at the y-axis at the origin? What does origin mean? Here, find an equation of the straight line that passes through 0, 5 and is perpendicular to L. So that's once again very much like question 21. Question 25, a straight line L is perpendicular to the line with equation y equals 1 minus 3x. Okay, the point with the coordinates 6, 3 is on the line. Find the equation. So the same kind of idea as question 21 once again. The gradient of this line is minus 3. So the gradient of the perpendicular line will be, well, you change the minus to a positive and you flip it upside down. So it will be a third. Okay, and the line has to pass through here. So when x is 6, y is 3. Okay, that's finding the midpoint of a line, so you should be able to do that. Okay, this is the midpoint of a line. Once again, you should be able to do that. Translating graphs, the graph of f of x is shown on each of the grids. On this grid, sketch the graph of y equals f of x minus 3. Think of that A3 sheet. What happens when you take 3 from the number first of all? It moves the graph. In what direction? Here, what have you done? Okay, it's been flipped. Here's your original graph. It's been flipped in the y-axis to this. The positives have become negatives and the negatives have become positives. Okay, which one of the things you did does that to a graph? Here, what's happened? The graph has just simply moved up. What is it you do to this to move it up by 3? This is a Cos curve, and you know that it is, well, you know what the shape of it is. It's in your book. Okay, and you know that it repeats every 360 degrees. Okay, so what is the value of this? Okay, what angle makes it, and what is the value of it? Question 30 should be fine. Question 31 should be fine. Okay, you're splitting 300 into 2 plus 3 plus 5, 10 equal pieces, and then giving 2 to Ali, 3 to Ben, and 5 to Candice. 32, transformations. Rotate it 90 degrees clockwise about the point 0, 1 to give triangle B. 0, 1 is there. That's where you're going to put the pen on your tracing paper when you turn it. Okay, make sure you go clockwise. Translated by a vector minus 3, minus 1 means a slide. Minus 3 means 3 to the left. Minus 1 means 1 up. Or no, it doesn't. 1 down. Beg your pardon. Let's say that again. Minus 3 is 3 to the left. This is your left-right number. Minus means left. Minus 1 is 1 down. Okay. I'm going to pause this video at this point here at question 32, and hopefully I can do a bit more of the video later on, but I'm going to save that and work on that and give it to you for the time being. Okay, cheers guys, thank you.